Okay, YouTube, this is my first video in a module I'm doing on lines and their slopes. And so we're going to start by defining what slope is. And as we study lines, a really convenient way to kind of indicate the tilt of a line, or I guess the slope of a line, how steep it is to measure the difference between a change in y or a change in x, or in other words, how much our graph rises compared to how much it runs. And so we have a ratio here that we use to define slope, but we say the slope of the line passing through two distinct points. So we're going to refer to these points as x1, y1, which will be the coordinates of this very first point you see here in the diagram, and then x2, y2. So long as we have 2 points on a line, we can actually measure how much the y values change by just saying it's y2 minus y1. That would be this geometric distance here. So our y2 minus y1, this indicates what we refer to as the rise of our graph, compared to the run of our graph. And the run of our graph is really just the change in distance in the x values. Like x2 minus x1 would give us this distance here. And so we would have this right here. And so the definition of slope is rise over run, or we could also define this as, given two distinct points, x1 and y1, x2, y2, it's y2 minus y1, or change in y values, over x2 minus x1, or change in x values, so long as x2 minus x1 is not 0. We can't have a 0 in the bottom of this ratio right here. So what I want to do is I want to find the slope of the line passing through these following pairs of points. You notice that I make a little note here that says, make a sketch to aid you in this. So we have some x1, y1 here. We're going to actually write this in here, x1, y1, and then we have x2, y2. What I'd like to do is find the slope of the line passing through these 2 points. So before I actually make a sketch on this one, I actually just want to show you that we can really just use this ratio right here, where we've got y2 minus y1 over x2 minus x1. And so y2 I would consider as being the y value of our second point here is a -2, and we have y1 as a 4. Now change in x values, we have to do this in the same order. So we say -4 minus our -3 here, and it is actually kind of important that we're subtracting a negative there. So we get -2 minus 4 more is -6, and then we have this, we have -4 plus a +3 after subtracting a negative, which is a -1. So we actually get a +6 here for a slope. Now one thing I wanted to do was make a sketch of this, and so to kind of aid us in this, what I'm going to do is use a program here. I'm going to go left 3, up 4, and I'm going to draw a dot there. And our other point that we had here was left 4, -2. So we'll go left 4 and then down 2. We said we wanted to find the slope of the line passing through these 2 points. So what I'm going to do is I'm going to cast a line through these 2 points. And another way we could have done this is just looking at the graph here. Could we count the rise from the height of -2 up to a height of +4? We could count 1, 2, 3, 4, 5, 6 in rise. And then from here to here, we would run 1. So if our rise is 6 and our run is 1, we get 6 over 1, or the exact same numerical value that we got over here. So we got a positive slope there. Let's take a look at the second slope. We could say, let's find the slope, and we'll say change in y over change in x, where our y2 is 5, our y1 is a -2. We would say that our x2 is -1, and our x1 is 4. And so subtracting these out, we get 7 on top, and then on bottom we get a -5. So we get a -5/7. And one thing that I want to do is I want to put that negative actually on top. And the last thing I want to kind of mention here before we talk about this last table is basically, when you talk about rise over run, let's always consider our run number to be the positive of the 2 values. Always positive. Positive run. And the reason why is because we tend to read graphs from left to right. So if you allow your top number to be the -1, then really what it's telling you is that you're falling 7 units or rising 7 units depending upon its sign. So again, really quickly, let's graph these 2 points. We have 4, -2, so we'll go right 4 and down 2. There's a point right there. And actually, we can, let's see, grab this other one, -1, 5. So let's see, -1, up 5. And I'm actually going to leave this on here just as a line, but I would count here 1, 2, 3, 4, 5, 6, 7 in falling values here, and then we run 1, 2, 3, 4, 5. So you can see that this algebraic approach is actually just as beneficial as using a picture approach. It's just all kind of how you want to do it. So the last thing I want to mention here is this. On the very first example, we got a positive slope here of 6. In the second example, we got a negative slope of -7/5. But you can notice here that as we read these graphs from left to right, anything with a positive slope is said to be increasing, whereas anything with a negative slope would be decreasing. If we were to consider something with 0 slope, we would have something that's neither increasing nor decreasing. It would be constant. So what we're going to write here is that positive slope is an increasing graph from left to right. So we have increasing graph from left to right, or it's rising from left to right, whereas negative slope is a falling graph, or decreasing from left to right, decreasing. And then if we have 0 slope, this means that really we have a ratio of rises 0, runs however many in terms of a constant here. It's always running but never rising. We would say that this is a constant graph. And then last but not least, we refer to an undefined slope. That is something where we are never ever running, but we're always rising. This would be division by zero, which means we have a vertical line.